Hey guys, this is Mr. Murphy here. Welcome to video lesson number 3. This one is going to be about some of the different questions you might be asked involving tangent segments and some of the properties you need to be aware of involving tangent segments. So here we go. For number 1, we're trying to find this length, the length from this point to the length on the outside of the circle. And we're going to assume that any lines which appear to be tangent are tangent. Now, just as a reminder, tangent means touches the circle exactly once. So any line or line segment that touches the circle exactly once is considered a tangent. So for instance, on our example, this 8-unit line would be a tangent because it touches the circle here and it continues on the outside. Okay, so number 1, to solve for this missing segment, we need to have the tangent here, and we see that the tangent is connected to a diameter, or a radius. We learn this as radius, but you can also use a diameter. So, in class, I believe we called this the tangent radius theorem, something to that effect. What this says is that anytime I have a tangent that connects to a radius at the point of tangency, they form a right angle. So basically, to summarize, tangent and radius make a right angle. Cool. Now, why is it important to know that? Because to find the length of this line that we are solving for, the right angle combines with the rest of these lines to form a right triangle. And we know that with right triangles, I'm going to go ahead and label the pieces that I have. That's 8 down here. We can use, I'm going to go over here, a squared plus b squared equals c squared. We can use Pythagorean Theorem to solve. Now, this is the side that we're looking for. I'm going to call that x. So I have an 8 down here. Sorry, let me try to make that a little more visual. That's an 8. So an 8 down here, and then we need the length of this side in order to solve for the hypotenuse. So let's look back on the picture. This length from here to here is 7.5. Now, very important piece that's going to help you with other circle problems. If I know this radius is 7.5, this one is 2. Any radius of the same circle is going to be equal. So I'm going to go ahead and put a 7.5 right there, which means that altogether, this entire side of the triangle is equal to 7.5 plus 7.5, or 7.5 times 2. In any case, that works out to 15 units. So my triangle is 8 on the bottom, 15 for the long leg, and we're solving for the hypotenuse. Now, when you're plugging in your sides to a squared plus b squared equals c squared, make sure the hypotenuse across from the right angle, like that, is always c. So in this case, x squared is going to go right there. And then the other two numbers, doesn't matter the order, you can go ahead and do 8 squared plus 15 squared, and then solve. 8 squared, 8 times 8, gives you 64. 15 squared, 15 times 15, gives you 225. Still equals x squared. Now we combine these. When I do 64 plus 225, what I get is 289 equals x squared. And then since x is not squared on the actual diagram, we now have to take the square root of both sides. I'm just going to draw one big square root sign to show that I'm taking the square root of 289 and the square root of x. Square root of 289 works out to 17, so x equals 17. If I were to write that on the diagram, that would mean this length from this point to this point is a length of 17 units. Cool. Alright, so this is something that you want to keep in mind with all circle problems. The fact that a radius will always be equal to another radius of the same circle. But in general, when you have a tangent and a radius and they make this triangle like that, the point where the tangent touches the circle and the radius will always make that right angle. That's the big takeaway here, because that lets you do this, do Pythagorean theorem. Okay, that's example number 1. That's one of the types of questions you might see with tangent segments. Let's move on to example number 2. For example 2, again, we're going to assume that any lines that appear to be tangent are tangent, and we are going to use these tangent segments to help us solve for x. So, I have a tangent segment right here. It has a length of 3x plus 16. And then I also have this other tangent segment over here, which has a length of 5x minus 4. Now, what do I notice that's interesting about these two tangents? Well, it looks like they meet at the same point on the outside of the circle. So two tangents meet outside the circle. Cool. Now, what we learned when that happens is that because they are both tangents and because they meet at the same external point, their lengths are equal. In other words, they are congruent segments. So I can mark them like so. That one is congruent to that one. Cool. Now if I want to solve for x, how does that help me? Well, that tells me that this length of 5x minus 4 equals this length of 3x plus 16. So it gives me a way to write an equation. I can do 5x, take away 4, equals the length of the other line, 3x plus 16. And then from there I can solve. So I'm going to draw my line down the middle, add 4 to both sides. On this side I have to add that to the 16. So 5x minus 4, add your 4 on both sides. This 4 cancels out, so I'm left with 5x by itself. Bring down the 3x, that comes straight down. 16 plus 4 gives me plus 20. Cool. Alright, so now all the numbers are together. So now I'm going to look at variables. I need to get my x's together on the same side. Since 5x is already by itself, kind of leave that alone. Let's move the 3x over. Since it's positive 3x, subtract. When I solve that, I get 2x equals, that cancels, so 2x is equal to 20. Rewrite that over here. So now that we've gotten 2x equals 20, last but not least, we have to get rid of that 2. So since that says 2 times x, divide by 2, boom. You get x equals 10. Awesome. Cool. So on something like this, when you see those two lines outside of the circle, remember they have to be tangent lines, which means touching the circle exactly once. If both those tangents meet at the same outside point to the circle, then their lengths are equal. Lengths are equal. Cool. Now, another question you might be asked to solve with this property is an example like example number 3, which asks you to find the perimeter of the polygon. And again, we're assuming that all of these lines that look like tangents are tangents. So to do that, use the same property. Anytime you see two tangents that meet outside the circle, their lengths are equal. Here's what that looks like. So I'm going to start at this top corner. I have one tangent going this way. Its length is 14.6. And then from that same point, I have another tangent segment that goes here. So using the same property, these two tangents meet outside the circle, so their lengths must be equal. So if that one's 14.6, that one is 14.6. I can continue to do this around the entire circle. So down here at the bottom, I see that this tangent has a length of 6.3, which means this part of it must be also the same length, 6.3. I see that at this corner, we have a tangent with a length of 5.6 down here, which means this one is also 5.6. And then back over here, at the last corner, I have a tangent of 4 units this way, which means this other tangent from the same point is also 4. So in other words, if you have a polygon surrounding your circle and all of its sides are tangent, basically if you look at every corner, the opposite side, so to speak, of that corner will have the same length. So these two sides of the corner are 14.6, 14.6. This corner, both sides are 4 and 4, etc. Cool. So now if I wanted to find perimeter, hopefully that when you see that, you know exactly what to do. You're just going to add all the sides. So I can add up all of these little pieces, but I can also do this. I can find the length of each of the sides individually. So for this side, that's 14.6 plus 5.6. So that works out to 20.2. Down here, same thing. 6 plus 3 is 11. 3 plus 6 is 9. So that's going to be 11.9. Over on this side, 4 plus 6.3 works out to 10.3. And over here, 4 plus 14.6 works out to 18.6. So since those are the lengths of my 4 sides, off to the right, where I have space to work, I'm going to add those. So 18.6 plus 10.3 plus 11.9 plus 20.2. Okay. Cool. So now I'm just going to add vertically. So 6 plus 3 is 9. 9 plus 9 is 18. Plus 2 is 20. So that ends in 0. Carry the 2. And then I do it again. 2 plus 8 is 10. Plus 0 is still 10. Plus 1 is 11. Plus 0 is still 10. So that's, 11. So that's 11. Bring down the 1. Carry the 1 from the tens place. Cool. So now in this column I have 1 plus 1 plus 1. So 1, 2, 3, 4. Plus 2 more is 6. So my perimeter should be exactly 61 units. Cool. So in other words, if each of these sides were measured in inches, this would be 61 inches all the way around that shape. That's my answer for perimeter. Okay, cool. Remember, if you have questions on a specific example that we did here, feel free to rewind the video, look at it again. Also, make sure you are thinking about coming to those virtual office hours. And then if you can't make it to office hours for whatever reason, feel free to just send me an EDSB message with your question. You can even take a picture or screenshot whatever example it is that you happen to be working on, and we can communicate that way. Have a great day. Bye-bye.